ship at a slightly nose-high attitude. When you have enough speed, the ship will take off by itself. You don't have to pull it off the ground. And it's got very little torque. You could pull it off at about 110 miles per hour if you were on a short field. But it'll fly itself off at about 130 miles an hour. Back now to normal rated power, which is 38 inches of manifold pressure. Give me 2,400 RPM on the propeller pitch control. 400. What were you watching during the takeoff? Psychrometer, manifold pressure gauge, and your thumb. If you ever get to be a B-26 pilot, don't waste any time giving the signal to get that gear up from the moment you're sure you're off the ground. Because? Because when you run out of runway, your landing gear is no good to you. Pretty tough getting to 160 miles per hour until that gear's tucked away. I see what you mean. Well, we're climbing now. We do that at exactly 160 miles per hour until the flaps are raised. The airplane should be at least 800 feet above the ground before you raise it. This is what is known as milking them up. You do it a little at a time, and you keep your hand on the flap handle until the flaps are all the way up. If you don't, and they should come up on one side only, you'll go into the most violent bank you ever saw in your life. But you can stop it by putting the flaps back down again. Can I take my eyes off the tachometer? Yeah. Put them on the hydraulic controls. It's time to neutralize them. All air work is done with cowl flaps, wing flaps, landing gear, and oil cooler shutters in neutral position at all times, in order to prevent loss of hydraulic fluid from the entire system in case one of the individual lines develops a serious leak. Turn off your boosters. Airspeed indicator says we're picking up speed. With the flaps up, the ship changes its attitude. You'll notice our noses come up a bit and gains about 10 miles per hour. With the cowl flaps half closed and the oil cooler flaps half closed, it streamlines the airplane to the extent that it picks up about 5 miles per hour more. But you must not forget that these controls should be handled in accordance with cylinder head and oil temperature. Really claws her way right up into those clouds, doesn't she? You fly her for a while, Jim. Get the feel of the controls. See how easily she handles. Nice. Try some shallow dives and climbs and a couple of gentle turns. Controls are easy, aren't they? Smooth as a GI haircut. Easy to coordinate, too. Hey, you're skidding, sonny boy. Take a look at that turn and bank indicator. What causes that? Something I forgot to tell you. The plane has a very sensitive rudder, and you'll skid on all your turns if you don't correct for them. Try it again. Another advantage of the B-26 is that it can be dived up to 325 miles per hour with a heavy load and pulled out without an appreciable strain on the airplane. But diving is about your one luxury. Side slips, vertical banks, and all acrobatics are prohibited maneuvers. I'll try to go straight and level, Dick. Try a 40-degree bank. That's the maximum. By the way, the B-26 is a good airplane to go to war in. It's got plenty of power, plenty of armor plate, and plenty of guns. I'm beginning to think it's a good plane to go anywhere in. Let me take over for a minute. I want to show you a power-off stall. Power-on stalls are prohibited in the B-26. This one will be with the nose not over 10 degrees above the horizon. 95 miles per hour with the flaps and landing gear retracted. About 115 miles per hour with the flaps down, and about 100 miles an hour with flaps and landing gear down. Notice the pronounced shuddering just before the stall. You'll also feel the lack of control when the control surfaces are moved. These are important points to remember, since it means that the airplane will always give you plenty of warning. Another advantage is that it falls straight forward from this type of stall with no tendency to drop off on either wing. Of course, in power on or nose high stalls, it may fall off on one wing. Normal stall recovery is very simple. Just put the nose down and let the ship pick up speed by itself. Loading is an important consideration in respect to stalling. If the ship is improperly loaded and the tail is too heavy and therefore the center of gravity too far to the rear, it will affect the stalling characteristics of the airplane by making it stall at a higher speed and with less warning. Improper loadings also have to put you into a spin.
That spin business fascinates me. Just how do you get out of one?
Cut your power off and make a normal spin recovery. Don't be slow and cautious in the movement of your controls during recovery. And avoid getting impatient waiting for the controls to take effect. Sometimes they need a little while before they begin to work. And the only way you can judge time is by counting the number of turns made. Don't use your throttle except as a last resort. When you're free of the spin, pull out gradually or you're apt to tear your wings off.
What about mental spins? How do I pull out of them?
About time we were heading for the barn. But before we do, I want to show you how this airplane flies on instruments. See how our gas is.
Look at that B-26 moving in on us.
Yeah, we'll have to keep our eye on him. Transfer gas to the main tanks. I'm going on instruments for a minute, and I want you to keep your eye on that B-26 from my side while I'm flying blind.
Yes, sir.
Hand me the blind flying hood. That 26 from your side, Jim. I'm going to let down to 4,000 feet to show you how easy it is to set a constant rate of descent in a B-26. Watching the instruments?
Them and that 26.
fuel pressure?
0.
Flip on the booster.
No rise in pressure. The field's in sight. Do you think we can make it?
I think so. I'm going to feather that dead engine. Watch me. The ignition switch is left on until the propeller has stopped turning. I center my ball and needle and slow up to 155, increasing my trim as I do.
Isn't that a lot of trim, Dick?
You need it because of the natural torque of the operating engine. Going on the right engine requires about 5 degrees more trim than if you were going on the left. The slower I go, the more trim I need. But I've got to watch that needle and ball while trimming. What's the airspeed?
155.
Between 150 and 160 is correct. But 155 is plenty fast for single-engine operation.
Shall I give him the bad news back at the tower? Tower from 7645. I'm about 8 miles west of field, 4,000 feet, operating on a single engine. Request instructions for emergency landing. Go ahead.
7645 from the tower. Field is clear for emergency landing. Wind is south 10. Go ahead.
7645, roger.
I guess I'd better hit the emergency salvo release. I didn't expect to have to demonstrate these emergency procedures so soon. Doors are open, so I had to nose down slightly to hold 155. How much altitude did I lose?
250 lovely feet.
I'm going to make a 90-degree approach, Tim. With all turns into the good engine. Turns made into a dead engine are invitations to a spin. Plenty high, so nose down slightly. Reduce right engine for about 24 inches manifold pressure. Landing gear down and check your instruments.
Didn't blow his horn.
Check your hydraulic pressure gauge. I've got the nose down again to hold 155. You're on the field side, so you'll have to tell me when to turn.
I can hardly wait. Now's the time, Dick. But you're plenty high, you're certain to overshoot.
That's the whole point of this type of approach. Always overshoot, never in any circumstances undershoot. You can always dive off excess altitude. The next step is to decrease the power on my operating engine until it's virtually shut off. And then trim a few degrees to the other side. One-quarter flaps. kind of a glide.
4 flaps now?
No, not until I'm positive I'm going to overshoot. Okay, full flaps. I picked up some speed on my dive, and I'll have to lose it by holding the nose up and letting the ship scoot.
Boy, these brakes are really good.
You can stop her at 1,500 feet.
Very interesting, Captain.
I hope you committed that reasonable facsimile of a single-engine approach to memory.
I certainly did. Say, by the way, what would you have done if you'd had to stop in a hurry and didn't have any hydraulic pressure?
I'd have had you give me more pressure on the hydraulic hand pump. If that hadn't worked, I'd have pulled the emergency air bottle, which is connected directly with the brakes.
Well, that's the fastest stop you can make, huh?
No, there's an even faster one. If you're going to run into something or the field is slick and you can't get any traction on your wheels, you can, as a last resort, pull back your mixture controls, cut your switches, and raise your landing gear. That'll stop you, but it's a little hard on the airplane.
Just one more question, Dick. Suppose we hadn't been able to make our home field.
We'd have picked out any field that was fairly flat and free from obstructions, brought the ship in on its belly. Aside from the wheels being up, the landing would have been the same as the one we made.
I know, but what about getting out?
Well, if we'd had time, we'd have got out of our parachutes and pushed the seats forward to get out of the path of the propeller in case one of the blades should break off when it hits the ground. Then just before we touched, I'd have pushed the mixture controls back to idle cutoff, cut the switches to keep down the fire hazard. Then the minute she touched, we'd have got the top hatches open, and then we'd have all got up and quickly walked away.
Come in.
Good afternoon, gentlemen.
Good afternoon, sir. I have an emergency landing to report.
Yes, the tower informed me you were coming in, and I watched you. It was a good job.
Thank you, sir.
Those simulated single-engine approaches you've been making came in handy for you, didn't they?
Yes, sir. The airplane was undamaged, and there were no personnel injuries.
What was the reason for the engine failure?
It was a personnel failure, sir.
No. Sit down, gentlemen.
Corporal Smith, our engineer, made a mistake in turning on the fuel transfer pump, emptying the left main tank instead of filling it. However, it was more my fault than his because I had him watching a nearby plane while I flew on instruments, and I neglected to keep an eye on my fuel gauges.
And where were you?
Sandbagging in the co-pilot seat, sir.
Sandbagging is right. That's another lesson for your collection, Captain. Live and learn. And I hope neither of you will forget it. I'm positive that Corporal Smith, or rather Private Smith, will not, since he's going to get some KP duty in which to meditate upon his sins. How do you like the B-26, Lieutenant?
I'm not kicking, sir.
Only our enemies are.